Okay, so there's a couple more trigonometric properties that we would really want to know when it comes to these trigonometric functions. And in fact, for three of these are really the same. This is called the period of a trigonometric function. We say that a trigonometric function is periodic, or any function is periodic, if the value for the function repeats itself over some particular point time t, right? So if f of x plus some period is simply equal to f of x, then we say it's a periodic function. Right? It's periodic. And sine and cosine and tangent, secant and cosecant, and all of them are like that. Let me show you how. Let's say that we pick some arc length t. And we find our sine and our cosine of t. Well, what else could we say? Well, if it's true for t, right, it's true for the coterminal angle t plus 2 pi, or 4 plus 4 pi, or plus 6 pi, or plus any even multiple of pi, right? So our function sine is the kind of function that says, well, if you take the sine of the angle t, it's the same as the sine of the angle t plus 2 pi. And so we're going to say that for our sine function, the period of the function is 2 pi. That's how long it takes for this function to repeat itself. The same thing can be said about cosecant. In the cosecant function, the cosecant of t is exactly equal to the cosecant of t plus 2 pi. So again, the period of this function is 2 pi. In fact, for all of these functions, cosine and secant as well, the period is equal to 2 pi. The only one for which it's a little different is the tangent and cotangent function. And here's why that happens. What we said, remember, if we used our sines rule right here, our sines rule said, well, if we had this circle, let me move this one over here, right? And we were looking at tangent and cotangent, we picked some angle right here. It would turn out that it doesn't matter where we put them. If we found an arc length here, and we found the equivalent arc length here, the tangent value would be the same. Well, those are separated by a distance of pi radians, right? Since all students take calculus, all of the trigonometric functions are positive in the first quadrant. Tangent and cotangent, by the way, are positive in the first and third quadrant. Then we would say that the tangent of an angle t is equal to the tangent of that angle plus pi. So tangent and cotangent are the only kind of oddballs when it comes to period. The period in both of those cases is equal to pi. Okay. Now, this might actually lead you to sort of an interesting example here, and let me talk about that example. Let's say that we were asked to use the unit circle definitions to find out what happens with cosine of t plus 2 t plus pi. Why isn't that the same as tangent? Well, in this case, cosine of t plus pi would be the same thing as the negative of the cosine of pi. Why, you might ask? Well, let's take an arc length t. Here it is, on our unit circle. The cosine is the x-coordinate, and the sine is the y-coordinate. So what happens if we go to t plus pi? Well, if we go to t plus pi now, that means that we go along the outer edge of this circle right here by pi units. So that brings us all the way over here into quadrant 3. Well, in quadrant 3, since this is our arc length right here of t plus pi, that the cosine of t plus pi would be the x-coordinate, and the sine of t plus pi would be the y-coordinate. So what could we possibly say about this situation? Well, our x-coordinate is going to be the same as the x-coordinate above, except that it will be negative. So cosine of t plus pi would be the negative of cosine of pi. All right, more to come.
Professor